In this video, I want to take a look at converting equations between polar coordinates and rectangular coordinates. These are the relationships we had for converting coordinates. That is, if you know r and theta, you can calculate x and y with these first two equations. If you know x and y, you can calculate r and theta with these second two. Remember, you had to be pretty careful converting in that direction. So now what I want to do is I want to take a look at equations. Like if you've got an equation like, oh, how about the equation of a line? Y equals 3x plus 2, right? How does that look in polar coordinates, right? What equation describes that same line, right? Because you know this is a slope-intercept form here. The intercept is 2, the slope is 3. You're describing this line. Is there a relationship that could be said if you look at all those points with their polar coordinates? What would have to be true? Well, it turns out that this conversion is really pretty straightforward in that you know that y is equal to r sine theta. So just plug it in. The x is equal to r cosine theta. So just plug it in. So what I have here is instead of y equals 3x plus 2, I have r sine theta equals 3r cos theta plus 2. The y was replaced by r sine theta, the x was replaced by r cosine theta. I've converted that equation into r's and thetas. Now, I may want to do a little algebra to this to make it a little more useful. Generally, when we're plotting graphs in polar coordinates, we like to have it as r equals a function of theta. We'll do a whole nother video on using your calculator and actually a substantial amount of plotting graphs in polar coordinates. But what I want to do here is I want to solve it for r. So I'm going to get this everything that's got an r in it over on the left. So I've got r sine theta. I'm going to subtract the 3r cos theta over here. Leave the 2 alone over where it is. Okay. Now I can factor an r out of those two. So r times sine theta minus 3 cos theta equals 2, and then I can divide by the stuff in parentheses there. So r is equal to 2 divided by sine theta minus 3 cos theta. And I've got now r as a function of theta. There's no x's and y's involved anymore. It's just r's and thetas. Okay. That turns out to be a really straightforward direction. No matter what the equation is, if you're starting with x's and y's, here's a simple, x squared plus y squared equals 9. You can just plug in. Now, I'm going to do it here, but it turns out this one happens to be easier to do another way. But if you just say, hey, look, I can replace x by r cos theta, that's going to be squared, and I can replace y by r sine theta, that's going to be squared. I have converted the equation in x and y's into now an equation that's in r's and thetas. Now there may be a simpler form of this, and I got to do some algebra to get there, but at least I can convert it. It's very straightforward to do. So actually doing a little bit of algebra here, this is r squared cos squared theta plus r squared sine squared theta equals, where did that 3 come from? 3? It's a 9, isn't it? It was a 9, still a 9. I don't know why that was a 3. Now you probably didn't hear the last thing I said, so you might want to rewind and replay that. Forget about the fact that I put a 3 there. That's a 9. Okay, still a 9. I was thinking 3 squared, I guess. I can factor an r squared out of this, and what's left with on the inside is cosine squared theta plus sine squared theta. And all of a sudden I'm feeling like I'm back in a trig class again because I've got identities coming here. That's 1, right? So this is just r squared equals 9, which might be more simple to say it's just r equals 3. Or r equals minus 3, but in fact, I could have gotten there right from the start because x squared plus y squared, remember, x squared plus y squared is r squared. So sometimes you can see bigger pictures here. You can see, rather than doing just the x and the y, say, oh, I got x squared plus y squared, I can replace that with r squared. Right? The graph of r equals 3 or r equals minus 3 is the same. It's a circle of radius 3 centered at the origin. And so I don't care whether you're facing this way and saying go 3 units, or facing this way and saying going negative 3 units. You're going to face in every direction in order to get all the points that satisfy this equation. And so as you do that, you will get whether you call it as r is plus 3 or r is negative 3, you're going to get that same circle. So by taking the square root of both sides, it may seem like I lose half of the picture, but I get it's the same picture just traced out again. So it's still describing that circle. Okay. Converting in the other direction is a little less straightforward. That is, if you're starting with an equation in polar coordinates and trying to convert it to x's and y's, it's a little trickier to do. For instance, ooh, my battery's dying here. For instance, if I just had something like, well, try to go the other way. If you just had r equals 3, you say, well, I'd rather have r squared. So I might be inclined to say, well, okay, r squared equals 9, and then I convert the r squared into x squared plus y squared. Okay, that was not too bad. How about something like, r equals sine theta? R equals sine theta. It's like, wow, I'd rather have an r squared, so I'm thinking about squaring both sides. But sine squared, what do I do with that? When I go back up and I look at my conversion equations, actually r times sine theta would be kind of nice, because that would be just y. So when I'm looking at that, rather than squaring both sides, I want to try something like, there's a couple ways people do this. I look at this and say, I'm going to multiply both sides by r. So I'm going to have r times r on this side, I'm going to have r times sine theta on that side. So this is r squared equals r sine theta. And I happen to know that r squared is x squared plus y squared, and that r sine theta is y. And now I've got an equation right there that's got x's and y's and no r's and thetas, so I've converted it. Now what the graph of that thing looks like, well, we'll deal with that in another video, but at least we've converted the equation. Another way people see this is they say, well, I know that r is maybe the square root of x squared plus y squared, and I know that the sine of theta is y divided by r. That is, you're looking here, that should be x squared plus y squared. So again, I'm looking at those equations up here, and the sine of theta is y divided by r. So I've got it partially converted at this point. Anyway, but there's still an r in there. Well, r is the square root of x squared plus y squared. So I've got the square root of x squared plus y squared equals y over the square root of x squared plus y squared. And then I multiply both sides by that denominator, and I end up back over to here, right? So there's several ways that people approach this, but it's much less straightforward than what we were doing above. You're looking for r squared, you're looking for r sine thetas, you're looking for r cos thetas. And then you get even some other weird things. I mean, here's what seems to be a simple equation in polar coordinates, just r equals theta. The graph of this thing we'll see is a spiral like that. As theta gets bigger, so does r. Convert that to x's and y's. Well, I can't imagine that this is going to have a very nice equation in terms of x's and y's. I'm trying to figure out how the heck would I do that. Theta is equal to the inverse tangent, kind of. I'm looking at this, grasping for straws here. Tangent theta is inverse tangent of y over x, and this is the square root of x squared plus y squared. But even still, it's plus. It might be plus or minus. This inverse tangent is really only giving me one thing. It's just not pretty. I feel a little better if I take the tangent of both sides and say that the tangent of the square root of x squared plus y squared equals y over x. And at least I think it's probably a little more accurate, or more of the graph here. I still feel like I might be missing some of it because I'm only using the plus square root and not the minus square root. I was thinking, well, maybe at this point I could square both sides, but then I'd have the square of the inverse tangent. It's like, that's kind of weird. So anyway, one direction of converting equations is pretty straightforward. If you've got x's and y's and you're going to r's and thetas, it's pretty quick. When you got r's and thetas, it's not so easy necessarily to get to x's and y's. You'll have to try some of these and ask your questions.